Welcome, this is the first advanced tutorial with B4D Tools. In this tutorial I will show you how to recreate this animation. You can see on the left side the original animation made with C4D with Mograph, and on the right side you can see the recreation with Blender and B4D Tools. You can check the original C4D tutorial made it by Nicolas Schetz in the description if you want it. The idea of this tutorial is to show that you can recreate animations made with C4D and Mograph in Blender with B4D Tools, and also that it is easy to replicate workflows of C4D in Blender. To do this tutorial without problems, I highly recommend using the 1.4.1 of B4D Tools version or higher, and Blender 3.6.5 or higher. Without further delay, I hope you like and learn a lot. Let's start. First select the cube and hide it. Then, add a Bezier spline. Tab to enter the edit mode, select all points and scale in the Z and Y axis. Rename the spline with the name Bezier curve _01. Change the dimension X size to 400 cm. Change the location X to -200 cm. With Controlled Command +A, apply the scale. Then apply the location too. With numpad 1 go to the front orthographic view. Tab to enter the edit mode. Select the right control point and move up 50 cm. Select all points, right-click and subdivide. Change the number of subdivided cuts to 2. Select the 2 right control points and scale it in the Z-axis to 0. Do the same with 2 left control points. Now fix the position of the 2 left control points to 0 in Z-axis. Then, fix the position of the 2 right control points to 50 cm in the Z-axis. Now move the right middle control point about 90 cm in the X-axis. Do the same with the left middle control but about -90 cm. Finally, adjust the handle control points to have a nice transition. This can be adjusted later as well. Now, we have finished all the work for the main path for the clones. Time to save the blend file. Unhide the cube and duplicate it. Hide the original cube. Select the duplicated cube, go to the B4D Tools and add a bicloner linear mode. Activate the Use Collection parameter and move the spline to the collection. Go to the bicloner parameters, change the P.Z to 0 and P.Y to 20 cm. Also change the count to 4. Close the bicloner linear modifier and go to the bicloner transform modifier. With numpad 7 go to the top view, in the bicloner transform set -30 cm in the parameter py. Close the collection and hide it. Go to the B4D Tools. With the object selected, add the Realize Instances tool. And close it. Select the bicloner object and change the name by bicloner_linear_splines_01. Select the collection, change the name to grp_Bezier curve _01 and hide it. Time to save the blend file. Create a new collection, rename it to grp_bcloners_linear_paths. Move the previous collection and the bicloner linear splines 01 to that collection. Now, we have the basic spline paths ready to create the clones. Unhide the cube object, set the scale to 20 cm, and then, apply the scale. Add a bevel modifier. Change the amount to 1 cm, and change the number of segments to 3. Finally set to Auto Smooth. Now we have the basic cube ready to clone and we can create the setup of the ZippedLoop. Select the cube, add a bicloner spline, collapse it and collapse the bevel modifier too. Go to the bicloner spline modifier, add with the pipe the previous spline's paths to the spline curve parameter. Set the count parameter to 80. Adjust the offset parameter to have the correct position of all clones on the splines. Go to the original spline, select and add a new Geometry Nodes modifier. Rename it to GN_sample_curve. Change the layout to the Geometry Nodes workspace, add a resample curve node in the Geometry Nodes editor. Expose the count parameter. Come back to Layout workspace. Set the count to 48. We did this to resample the curve to an uniform subdivision without change the original shape, and with this we have better control of clones. Now we can adjust the handles of the curve to find a better transition. Rename the cube with bcloner_spline_rail_01_top. Collapse the modifier, add a new geometry nodes modifier and create a new geometry nodes tree. Rename it with gn_clean_instances_duplication. Change the layout to the geometry nodes workspace. We take a look in the spreadsheet and we see the number of instances, it's a higher number. Remember we create 80 instances with bcloner, but here we see 323. So we need to delete the unnecessary instances. Add a delete geometry node, change the mode to instances, in the selection input add a compare node, and in the A input add the index field. Change the mode to less than and in the input B set 243. With this node, we delete the unnecessary instances. Come back to Layout Workspace. Time to save the blend file. Go to the Geometry Nodes workspace, there we can expose the input B, and rename it to less than. With this, we can control it in the future without going to the Geometry Nodes editor. If we take a look closer, we can see the cubes are intersecting a bit, so we can do a little modification to improve this. Add a new Geometry Nodes modifier. Move the modifier to the top. And create a new Geometry Nodes tree. Go to the Geometry Nodes workspace. Here, search for the MTK_offset_origin node. This node it's available for free in my MTK Toolkit Geometry Nodes collection, so check it, link in the description, if you want to use it. Now change the geometry nodes created by the MTK offset origin node. Come back to Layout Workspace. Move the position Y to 0. This node allows to modify the origin of any geometry without editing. Now, we can adjust again the handles of the original curve to have a better transition, because now we can see the all clones and how they work. Take your time to find the best result. Time to save the blend file. Deactivate the offset origin node temporarily. Now, we have ready the top rail of clones. Time to animate it. Go to the bcloner modifier and set a keyframe in the offset parameter in the first frame of the scene. With Shift+D duplicate the keyframe to the end of the scene. Go to the first keyframe and set 0.4999%, insert the keyframe. Go to the middle frame of the scene and set -0.003%, set a keyframe and go to the final keyframe and set -0.4999%, set a keyframe. I decided to create 500 frames for this animation. Feel free to set up your custom frame range. The key here is to have the clones in the correct position on the different keyframes. Go to the animation workspace. Here, change the interpolation of the animation to linear interpolation. Come back to Layout Workspace. Now we check if the loop works correctly. If not, we can adjust it. To check, go to near the end of the animation and play to see how it works with the initial animation and see if the loop works or not. Collapse the modifier. Go to the B4D Tools and with the bcloner object selected, add the effector random. Activate the visibility parameter. Duplicate the bcloner_linear_spline_01 and rename it to _02. Duplicate the selected collection and rename it to 02. Rename the spline as well. Replace the collection Bezier curve 01 in the collection parameter with the collection Bezier curve 02. Select the curve and rotate it in the z-axis. Apply the rotation with Ctrl+A. Organize the Bezier collections into one collection and hide it. Select bcloner_spline_rail_01_top, duplicate it and rename bcloner_spline_rail_02_bottom. Go to the spline curve parameter and replace it with the object bcloner_linear_splines_02. Go to the random effector and activate the invert random parameter. Select and delete the curve called Bezier_curve_02. Duplicate the Bezier_curve_01 and move to the collection grp_Bezier_curve_02. With that curve selected, go to Edit mode, select the right control points and move in Z-axis to -50 cm. Now we have the two main bicloners ready with the setup done as well. Collapse the collections and hide the parent collection. Collapse again the collection and create a new one. Rename it with grp_bicloners rails. Put the bicloner objects and the empty controller into it. Time to check if the animation works. As you see, it works nicely for now. Time to save the blend file. We take a close look, we can see little problems with the intersection between the different cubes, so we can turn on the offset origin modifier in both bicloners. In the second, change the position Y to 1. Go to the collection linear paths and open it. Select the bicloner linear splines 02, move in the Z-axis -10 cm, and do the same with the other bicloner but with 10 cm. As you see now, the transition it's better, you can improve it more if you want, but for this tutorial, I will keep with this. Time to add a new camera and set a view similar to the reference. I changed the format size to 1920 by 1920 because with this you can adapt later the render for landscape and portrait versions. Now, I organize a bit the outliner with colors and names. It's important to keep organized especially with complex projects. Create a new collection and rename it as grp_cameras. Move the camera to that collection. Now we decide the view to that camera, so we can do this, moving and checking how looks the scene. Take your time with this and find the best possible view. Personally, I changed the passport of the camera towards a fairly dark color. This helps me a lot to see exactly what the camera views. Final adjustments with the camera view and we can see how the animation works too. For this tutorial, it works nicely, so we start building the rest of the scene. I reorganize a bit in the outliner. Go to the original bottom spline path and duplicate it. Move it outside that collection and then we will use it to build the floor. Create a new collection called grp_ground and rename the spline too. Now we will work with the ground. Select the curve and add a new geometry nodes modifier. Rename it with gn_quick_loft. Go to the geometry nodes layout. Add the curve to the mesh node. Add a curve line to the profile curve input. Adjust the start and end in the x-axis. Change it to fill the frame of the camera. With Shift plus A search the MTK_spline_linear_extend or append from my toolkit free, link in the description. Add to the curve and adjust the extended parameter to fill the front and back of the camera. Move the spline to the collection and rename it gn_spline_ground. Duplicate it and we will use it for the ground path. Add the MTK_combine_xyz_meters, copy and paste the parameter in the x-axis, duplicate it, and do the same with the end parameter. Expose the both x-axis. Rename the inputs, left extrude and right extrude. In the modifier, adjust both exposed parameters to create the path. Then adjust the position in the z-axis to separate a little bit from the ground. Collapse the modifier and add a solidify, move a bit in the Z-axis, activate the fill option in the solidify modifier, and then adjust the extrude right or left parameters in the previous modifier. Rename the object with _path. Go to the Geometry Nodes layout and select Quick Loft Node Tree, add the set material and expose the material socket. With this, we can add any material without going to the Geometry Nodes tree. I check again the animation to ensure that everything works fine. Time to save the blend file. Now we can work with the materials and the illumination of the scene. We start with the basic materials. I use the reference to create a similar feeling. Activate the look and dev, with the path selected, create a new material and rename it with ground_path. Go to the shading layout and in the shader editor, set a yellow color in the principled shader. Add this material to the material slot modifier. Go to the camera view and adjust a bit the yellow color. Select the ground and add the same material in the modifier. In the material slot, select the material and rename it as ground. Select the path and convert the material to a single user. Rename it to ground_path. Change the color to blue color. Adjust the roughness to have a soft specular. Time to save the blend file. Collapse all collections, create a new collection and call it grp_studio_lights. Here I put the lights of the scene. Add a sunlight in that collection, go to Render Viewport, check the light scene parameter and then adjust the rotation and the position of the light. I try to find the best light for the scene to see the nice shadows and illuminate the cubes. Take your time to do this. I speed and edited this part to keep short this tutorial. Again, I adjust the ground color to find a similar color to the reference picture. Here you can use any color if you want. I reorganized a bit the outliner with some changes and added some colors to the collections to keep them organized. Time to save the blend file. We finished the lighting part, now I start with the modeling part. You can skip this part if you don't need to know how to do the modeling of the cubes. I use a separate file to do this part. Start with the basic cube and activate the X-ray view. Tab to enter in the edit mode, select all faces, duplicate them with Shift+D, and scale them until to have a small cube. Select one edge of the inside cube and then the same edge in the outside cube. With F filled with one face, do the same with the rest of the edges. Activate the solid view, delete all previous modifiers and add a wireframe modifier. Activate the relative option and set 5 cm in the thickness parameter. Set offset to -1, with this parameter you ensure the size cube is the same as the original size of the original cube. Now we have the modeling of the first cube done. I activate the collection that I prepared for the all cubes and move it to the first collection, renaming the cube with msh_cube_wire. Duplicate the previous cube and delete the modifier, tab to enter in edit mode, select one face, make an insert faces and set the thickness parameter to 1 cm. Do the same with the rest of the faces. Change the transform pivot point to the bounding box center option to ensure the extrude will work correctly. Select all inner faces, invert the selection and extrude the selection. Again, select the inner faces and use an insert faces to make a small cube. Do the same again to have another inner cube, but this time with a slight size difference. Select the middle faces and do the same with the rest of the cube. Extrude, use the top orthographic view to ensure the extrude it's the same size as the first extrude. Select the inner face and do the same with the rest faces of the cube, delete all of them. Because we used the previous cube, we need to delete the interior faces and cube, so go to the X-ray view mode and delete the interior faces. Now select the interior edges and extrude them. Use the right orthographic view to check the extrusion, and then do the same with the rest of the faces. Go to the interior of the cube, use the X-ray view mode and with Merge with shortcut M, merge the vertices of all corners. Do the same with the rest of the vertices. Finally, adjust with scale the large faces of the cube, and then do the same with the rest of the faces. With this, we have done the second cube and we can start with the modeling of the final cube. Rename the cube with msh_cube_extrude_02. Duplicate the msh_cube_wire_01 and rename it msh_cube_details_03. Activate X-ray mode and delete all interior faces. Then go to Edit mode and add one middle edge in all the faces of the cube. Select all middle points of every face. With Shift plus Ctrl plus B, create a bevel vertex of every point selected and adjust the width to 4. Select all edges of the cube, with Ctrl plus B, add a bevel to every edge, adjust the parameters, change the segments to 2, and move the shape to 1. With this, we keep the shape of the cube. Change the width to 0.75 cm. Select all big faces, and insert the faces selected, change the thickness to 0.25 cm. To the actual selection, add the interior path selection, and check to ensure the all needed faces are selected. Invert the selection, extrude to the inside and then adjust the scale a bit. Now we finish the last cube modeling part. We check all cubes have the same size, if not we can scale and apply the scale to the cube. Last check for all cubes, they are ready to use in the final scene. Go back to the previous project and I append the two collections from the cube modeling project. Collapse the two appended collections. Select the top bicloner and replace the collection with the collection shapes_01_top. Activate the Use Collection parameter. And do the same with the bottom bicloner. Go to the bicloner transform modifier and set -10 cm in the y-axis, and with the other bicloner do the same but with +10 cm in the y-axis. Now we take a look from the camera view and check if everything works fine. Finally, we will work with the final render look. Activate the render view mode, select the bottom bicloner and add the ground_path material. Go to B4D Tools and add the global material modifier. Then add that material to the material parameter. Make a single user that material in the material properties in the shader, and rename it to base_assets. Then add that material to the material parameter. Adjust the roughness and the specular parameters. Add clearcoat too. Go to the render properties and set the ambient occlusion parameters, distance 50 cm, factor to 1. Another touch in the roughness parameter. I check the animation, select the MSH_cube_wire_01, create a new material, set the color to black, and adjust the roughness and the specular parameters. Select the MSH_cube_extruded_02. Add the ground material, set as a single user, top_orange_assets. Adjust the roughness and specular parameters as well. We check the material and how it works with the animation. More adjustments on roughness and specular parameters. Try to find the best look and similar to the reference. Select path ground and change the color a bit, same with the bottom cubes and the top cubes. Here you can take your time to adjust the different materials and colors. I see to have to fix the modeling of that cube, so I will isolate it, then select the faces and extrude and scale to create more space in the details. I used the same techniques that I used for modeling, so I edited this part to keep short this tutorial. Now we have done this fix and works fine with the shading and ambient occlusion. I adjust a bit more the material parameters and ambient occlusion. Check the animation again and now works beautifully. Now we can deactivate the offset origin and bevel modifier. It's optional, but with the collection, those two modifiers don't work. Final adjustments with camera position. Try to find the same view as the reference. To fix the ground to fill all camera views, duplicate the ground and adjust the extrude modifier parameter. Go to the sunlight and adjust a bit the rotation to have the best position of specular and shadows in the scene. Adjust the angle parameter and the shadow parameters as well. Time to save the blend file. Go to the world shader, here with Ctrl+T, remember to have the node wrangler activated. Then I changed the HDR with a custom HDR downloaded from HDR Haven. I highly recommend checking this website. Rotate the HDR to find a better illumination of the scene and adjust the strength as well. Once again I adjusted the specular, roughness and colors to have a bit more accurate materials concerning the reference. Duplicate the sunlight and rename it as area top. Change the type to area light. Set 65W to the strength, diffuse to 0.9 and specular to 0.41. I adjust the position, rotation and scale of that light to fill the scene and add more light and specular to the scene. Time to save the blend file. Change to Compositing layout. Activate Use Nodes. Now we work with the compositing part. This is the final part of this tutorial. Add a hue saturation node, set hue 0.502 and saturation 1.083. This node adds a little more color saturation. Add RGB curves and move the middle point to 0.4 and the left point to 0.9. With this node you can control the black and white colors. Add a mix color, change the mode to multiply and connect to socket A. Add ellipse mask, set 0.6 in the X parameter and 0.45 in the Y parameter. Width X with 0.720 and height 0.700. Add a blur node, set 200 in both axes. Connect to the socket B in the mix shader. Set the factor of the mix node to 0.593. This setup creates the vignette effect to help the focus of the viewer. I reorganize a bit the nodes and add a lens distortion node, set 0.04 to the dispersion parameter, and with this, you create a soft chromatic aberration. Create a new window layout on the left side, activate the viewport render and select the camera in the compositor option. This allows to use of the real-time compositor. Now, I mute all nodes and activate them one by one to see how affect and do final changes in real time. I deactivate the overlays and we can see how works with the animation. One final adjustment, duplicate the top area light and resize and move to give more light to the bottom biclona on the right side. Reduce the intensity of that light. Deactivate the Use Shadows parameter of that light. I deactivate the overlays and we can see how works with the animation. Finally, I renamed and organized a bit the outliner with the last changes. Save the blend file. So, that's it. I show again the final render. I hope you like it and you learn a lot. See you in the next video or tutorial. Thanks for watching.